Here's an example of how we can use linear equations in standard form. Let's read. Suppose you have been given the task at your job to purchase new cell phones and tablet personal computers for an employee group. Your boss gives you $6,500 to do so. After research, you discover that the PCs cost $230 and cell phones cost $155. So part A here, write a linear equation in standard form that relates the number of tablet PCs P and the number of cell phones C you can purchase with your budget. So the idea here is we're going to use all of $6,500 to purchase so many PCs and so many cell phones. So a linear equation in standard form would mean we're going to use, well, this is what it would look like. So I'm going to write down 6,500. Since we're going to use all of 6,500, it costs $230 for every PC. So 230 times P will give me the amount I will spend on purchasing PCs, right? $230 for every P that we purchase. I'm also going to spend $155 for every cell phone. So $155 for every cell phone. So that constitutes the amount I'm going to spend on cell phones. That constitutes the amount I'm going to spend on PCs. And I'm going to use all of that. So the idea is to add both amounts together and to set them equal to 655, indicating that we're going to use all of it. If we were going to use not all of it, maybe a portion of it, then that could be a less than sign. But that equal sign saying we're going to assume we're going to spend all of our 6,500, which is what we normally do, right? Given money, we spend it all. Okay, solve your equation. So this is in standard form, right? Both variables are on one side of the equal sign. This is what we call standard form. It's in the general form of ax plus by equals c. We're dealing with p's and c's here. Next, solve your equation in part A for p. That means this variable here. In other words, find a linear function in slope-intercept form that expresses the number of PCs P as a function of the number of cell phones C. So the idea here is when we solve or isolate this P variable, we will be finding an equation in slope-intercept form, and that will be, the idea here is that P will be a function of C. Remember, when we isolate one variable on one side of the equation, that's our output variable. So this is going to be, P is going to be a function of C. So to do that, we start with our equation in standard form. So to get P by itself, remember we do the reverse order of operations in reverse order. So the idea here is to get rid of this 155C first from both sides, and that is subtract 155C from both sides. So I'm writing it in a horizontal fashion. Hopefully it helps you understand what's happening. So minus 155C on both sides. That will give me a 0 here, leaving me with 230P on the left and this quantity on the right. To get P by itself, I got to divide by this coefficient, 230 on both sides. That looks like this. On this left side, that 230 and 230 will reduce to a 1. And recognize that 230 hits both pieces of that subtraction in division, so it looks like this. And what we have here is P equals that value. That right there you can verify on your calculator. That's that approximated. And then this right here, actually we can reduce, and our fraction, we can get a fraction for that in our calculator, and I'll show you how to do that. So let me clear out my work here. So 155 divided by 230. If I hit enter, I'll get a decimal. But if you hit this math button here, you'll see that number 1 fraction, hit enter, and the answer will turn into a fraction. I'm going to hit enter one more time, and that's the fraction in lowest terms. So 3146 is equivalent to that, just in lowest terms. So the fraction simplified for me. So what we have here is this guy, and I could write it this way too, with that subtract 3146 over C. I can write that as a negative C, just switching these two. Either one is fine, but recognize that both of these are in slope-intercept form. So P is a function of C, There's my slope. There's my vertical intercept. There's my slope, negative 3146. There's my vertical intercept. So the idea now is to ask us questions. I'm going to ask you questions about the vertical intercept and the slope and ask you to interpret. So let's take a look at a couple of those. Find the vertical intercept of the graph of the function and interpret. Well, the vertical intercept is the guy that doesn't have the input variable. That's that guy. So remember, it happens when the input is 0. So the vertical intercept is this 0, comma 28 points. Actually, 26. 26. That should be a 26. Okay, so let's interpret. So this is a C value, and that's a P value. C was the number of cell phones we purchased. P is the number of PCs we purchased. Well, the idea is if you purchase no cell phones, you can purchase that many PCs. So that's a good interpretation. If you buy no cell phones, then you can buy approximately 28.26 PCs. All right, let's look at the horizontal intercept. Find the horizontal intercept of the graph of the function and interpret. So the horizontal intercept occurs when the output is 0. So we want to find out where that where this guy reaches the 0 marker. So replace that with 0 and solve for C. So it looks like this. To get C by itself, you got to subtract that from both sides and then divide by that quantity. So let's subtract 28.26 from both sides. That looks like this. The left side, I'll give me a negative 28.26. That goes away, leaving me with that. So to get C by itself, you got to divide by that quantity on both sides. So that really leaves me with C equals that divided by that quantity. And we can input that guy into our calculator as such. So that's negative 28.26 divided by this fraction here, 31 divided by 46. So 41.9 we'll call it, 41.9. So C is approximately 41.9. Well, what does that mean? Here's the horizontal intercept, sorry, 41.9 comma 0. Alright, so we got to interpret that. That is a C value and that is a P value. Now I don't have room to write it here, but you would interpret it